Imagine leaving your house keys under the doormat, but for your entire cloud infrastructure. That is the reality of an API key leak. The recent Microsoft Azure API key exposure served as a stark wake-up call for the industry. It wasn't just a glitch, it was a lapse in protocol. In the Azure ecosystem, these keys are often the keys to the kingdom, granting broad access to storage, compute resources, and sensitive user data. When these keys are exposed, they bypass standard login screens and multi-factor authentication entirely. So, why do these leaks keep happening? It's rarely a sophisticated hack at the start. It's almost always human error. Developers are under immense pressure to ship code fast. Sometimes, convenience overrides security. A developer might hard-code a key into a script to test a feature quickly, intending to remove it later. But later never comes. That script gets committed to a Git repository. If that repo is public or becomes public, the key is instantly compromised. And I do mean instantly. Hackers have automated bots scraping public repositories 24/7 specifically looking for these strings. Within minutes of a leak, attackers can deploy crypto mining scripts on your servers, racking up massive bills in your name. Or worse, they can exfiltrate customer databases, leading to severe regulatory fines and reputational damage that is hard to recover from. This brings us to our first major line of defense: key rotation. This is not optional, it's essential hygiene. Rotation means invalidating the old key and issuing a new one. It limits the lifespan of any single credential. You should have a policy to rotate keys automatically every 30 to 90 days. If a key is stolen, it becomes useless before it can be exploited long-term. Tools like Azure Key Vault can automate this process, ensuring that applications always fetch the latest valid key without code changes. But rotation protects you after a leak. We want to stop the leak from happening in the first place. That requires scanning. Secret scanning tools act like a spell checker for your code, but instead of typos, they look for high-entropy strings like API keys. You should integrate these scanners directly into your CI/CD pipeline. They can block a code commit if it contains a secret. Don't just scan new code. You must also scan your entire commit history. A key deleted in a new commit still lives in the history. The ultimate solution, however, is to eliminate keys where possible. Use managed identities for Azure resources. This allows your services to authenticate with Azure AD without you ever handling or leaking a credential. Let's recap. Humans make mistakes, so remove the temptation to hard-code keys. Rotate your credentials regularly. Implement automated secret scanning in your workflow, and move towards passwordless authentication methods. The cloud is powerful, but it's only as secure as your weakest key. Stay vigilant. Thanks for watching. Subscribe for more security insights.